API authentication, end-to-end. One header line, 4 layers stacked on top of it, and one check that lives outside all of them.
You have sent this line 1,000 times. Authorization, the word bearer, then a long string. You copied it from a tutorial once. It worked, and nobody looked at it again. Then a new person joins the team and asks 3 questions. Is that string a JWT? Do we use OAuth, or do we use JWT? And the third one, which is the one that actually bites, the token is valid, so may this user delete invoice 88? Every one of those needs a word that has not been said yet, and each word has a relationship to the ones before it. That is the part almost nobody teaches, so that is what we will build here, one relationship at a time.
The subject is API authentication, end-to-end. Authentication means how does an API work out who is calling it. This is not a video about hashing passwords, about TLS, about cookies against tokens, or about RBAC against ABAC. Each of those has its own video on the channel. This one is the line that joins them together. We go in 4 steps. The header, split into its 2 halves, the token, which comes in exactly 2 flavors, OAuth 2.0, and then OIDC on top of it. And fourth, RBAC. Watch that 4th step. It is not a harder version of the first 3. It changes the question completely.
Before any code, one picture, because it kills the confusion that costs people the most. Think of a building with a ticketed entrance. On the left, the gate. You hold a ticket and there is no name printed on it. The gate checks the ticket, never the person. Hand it to a friend and the friend walks in. Drop it and a stranger who picks it up walks in too. Same ticket, 3 holders, same answer every time. In. Now the right-hand side. You are inside and you reach an inner door. Here you need a staff badge with your photo and 1 printed line, your job. The lock reads the job, not the face. So the same badge, worn by the same person, opens the main corridor, opens the storeroom, and is refused at the payroll office. A token is the ticket. A role is the badge. 2 separate checks, and almost every beginner writes only the first.
So the line itself. Here is the thing most people never notice. That is not one thing, it is 2. The word bearer is the scheme. The scheme says how you are sending the credential. It does not change, it is not secret, and it is the same fixed keyword in every request your app will ever send. The long string after it is the credential. That is the actual secret, the thing that identifies you, that you must not leak, and that expires. This split is not a convention somebody invented for JWTs. It is RFC 7235. The authorization header is always a scheme, a space, and then some credentials.
Which raises an obvious question. If bearer is a scheme, what else could stand in that spot? 4 are common, and the axis they differ on is how the credential travels. Basic sends the username and password, base 64 encoded, again on every request. Digest sends a hash challenge and answer, so the password itself never crosses the wire. Bearer sends a token. Whoever holds it gets in. And an API key is a fixed key, usually given to an application rather than a person. Bearer is one 4 keys. There is also a way back. Call a protected endpoint with no credentials, and a well-behaved server answers 401 and names the scheme it speaks. That is how a client finds out what to send.
The word bearer is doing real work, and that promise is the entire security model. A bearer thing belongs to whoever is holding it. A cinema ticket, a banknote, no name on it, no second check. So a bearer token means exactly this. Whoever holds this token gets in. The server checks that the token is valid. It never checks that you are the one presenting it. Every practical rule falls straight out of that. Send them only over TLS because anyone who reads one on the wire simply is you, as far as the server can tell. Keep them short-lived because expiry is the only thing that eventually stops a stolen one. And never put one where it gets locked.
Now the other half of the line, that long string. Here is the split most explanations skip entirely. The credential comes in exactly 2 flavors. 2. The axis is simple. Is there anything inside the string or not? The first is called opaque. It is a random string. It means nothing by itself, and that is the point. To find out who it belongs to, the server looks it up in its own store, 1 row per live token. And a good server does not keep the token in that row. It keeps a hash of it, exactly the way it keeps a password.
The second is a JWT, a JSON Web Token. A JWT is self-contained. The data is inside the string, and the whole thing is signed. So the server looks nothing up. It verifies the signature with its key, and then trusts what it just read. Let us draw the system once and reuse the same drawing for the rest of the video. 4 boxes. Top left, the browser. It runs your page and holds whatever string it was given. Bottom left, the issuer, which for now is your own login endpoint, the only place a password is ever checked. Top right, your API server. It reads the authorization header and decides whether the token is real. Bottom right, the token store, 1 row per live token, holding a hash. 3 arrows, and every one goes both ways. The browser logs in and a token comes back. The browser sends the token and gets an answer. The API server looks the token up and gets a row. That last arrow is the opaque flavor, drawn. Every request pays for it, and deleting that 1 row kills the token on the very next request. Now the same 4 boxes with a JWT instead. The lookup arrow is gone, crossed out. No row is ever written, so the store is not needed. The API server checks the signature on its own and moves on. But look at what replaces that arrow. Nothing. There is still no arrow between the issuer and the API server. Nothing travels between those 2 boxes. They simply both know the same signing key, which is a badge on each box, not a wire. And now the cost. If no row exists, there is nothing to delete, so you cannot unissue a JWT. It is valid until it expires. Full stop.
So here is the honest trade, and both columns are true. Opaque costs 1 lookup per request, revokes instantly because you just delete the row, and has nothing readable inside it. A JWT costs 1 signature check, cannot be revoked before it expires, works in a service that can reach no store at all, and its contents are readable by whoever holds it. Neither is more secure than the other. They fail differently. Choose opaque when you must be able to end a session immediately. Choose a JWT when many services must verify without all sharing one store.
One line about JWTs catches almost everybody out, so let us just run it. A JWT is 3 parts joined by dots: header, payload, signature. Take any token you have ever been given, split it on the dots, base 64 decode the middle part, and print it. No key, no library, no permission. There are your claims, in plain text. This is not a vulnerability, it is the design. Signed is not the same as encrypted. The signature guarantees that nobody changed the payload. It does nothing to hide it, which gives you one hard rule. Never put anything secret inside a JWT payload. And that limit is exactly why refresh tokens exist. This is the edge that makes them make sense. A JWT cannot be revoked, so you buy revocation back by splitting the job into 2 tokens. The access token is a JWT, verified locally with no lookup. It lives about 15 minutes, and it is sent on every request. If it leaks, it dies on its own, soon. The refresh token is usually opaque, a real row in a table. It lives for days, and it is sent rarely, only to get a new access token. If it leaks, you delete the row. You are not choosing between them. The pair exists because neither alone gives you both a cheap check and an instant cancel.
Now, OAuth 2.0 arrives, and I want you to watch what does not change. Same 4 boxes. The issuer, bottom left, is now a machine you do not run. Google, Okta, or your own separate identity service. It runs the redirects and the consent screen you have clicked through 100 times. And that is the whole difference. OAuth 2.0 is a protocol for the left-hand arrow only. Redirects, a consent screen, and authorization code, a client secret. The right-hand side of this picture is untouched. Your browser still sends a token. Your API server still verifies it by a lookup or by a signature, exactly as before.
Which kills the most expensive mix-up in this subject. OAuth 2.0 is not a third flavor of token. It does not sit next to opaque and JWT. It sits above them both. It is the protocol that issues tokens, and what it hands you may be opaque or may be a JWT. It genuinely does not care. RFC 6750, the spec for using bearer tokens, deliberately says nothing about the token format. So the sentence, "We use OAuth instead of JWT," is not a sentence. it compares a protocol with a file format. We use OAuth 2.0 to issue short-lived JWTs, on the other hand, means something.
Which leaves one more layer, one step further up the same axis, OIDC, which stands for OpenID Connect. OIDC does not replace OAuth 2.0, and it does not compete with it. It is a layer added on top of it. Here is the whole graph, bottom to top. At the bottom, the authorization bearer header, which is how the credential is sent. Above it, the token itself, Opaque or JWT. Above that, OAuth 2.0, which issues that token. And on top, OIDC, which extends OAuth 2.0 and adds the one thing OAuth never asked about, who the user actually is. It does that with a second token, called an ID token, and an ID token is always a JWT. So every OIDC login is an OAuth 2.0 login underneath.
Now stop, because the question is about to change, and this is the part I most want you to take away. Everything so far answered one question: who is calling? The header, the scheme, the credential, the lookup, or the signature, OAuth issuing it, OIDC naming the person. All of it ends with one answer. This request is user 4021. That is authentication, and it tells you nothing about the next question. May user 4021 read invoice 88? May they delete it? May they delete any invoice? Nothing in the token can tell you. That question is called authorization, and it is a different axis, not a harder step. This is the single most common mistake in the area, treating a token that verifies as a token that permits. A valid token is not permission. It never was.
RBAC is the usual answer to that second question. It stands for Role-Based Access Control, and it is 3 boxes. On the left, the user 4021. That is all the token proved. In the middle, a role, billing clerk. A role is just a name for a job. It is assigned to the user, and it lives in your database, not in the token. On the right, permissions, invoice read, invoice write. Permissions are verbs on kinds of object, and a role grants a set of them. The route names one permission and asks, does this user hold it? Move a person into a different role, and every route obeys at once. That is why roles exist, instead of a list of permissions bolted onto each user.
Right. The code walked in the order the request actually travels: issue, send, verify, authorize. Step 1. The server issues the token. This login route is the only moment in the whole system that a password ever appears. Check the email and password once. If they are wrong, 401. If they are right, build a small payload. Sub is the subject, the user ID, and that is the whole point of the token. IAT is when it was issued. EXP is when it stops working. Then sign that payload with a key and hand the result back. EXP is not decoration. It is the only break you have on a leaked token. And the key never leaves this machine, which is the only reason the signature means anything. Step 2. The client sends it. This half gets skipped in almost every explanation, and it is the half that actually produces the header we opened this video with. In the browser, you call the login endpoint with the email and password, and you read the access token out of the answer. Then, on every call after that, you set one header, the word bearer, one space, the token. That line is literally the line at the top of this video. One question is genuinely hard here. Where do you keep that token? Local storage is readable by any script that ends up on your page, which turns one scripting bug into a full account takeover. An HTTP-only cookie cannot be read by JavaScript, but it rides along automatically, so it needs cross-site request forgery protection. There is no free option.
Step 3. The server verifies it. Declare the scheme once. That HTTP bearer object parses the authorization header and refuses anything that is not bearer. Then, in one call, decode the token with your key. That single call does several checks at once, and I ran them all. Change one character of the payload, and it raises signature verification failed. Let the token pass its expiry, and it raises signature has expired. Hand it a token whose header claims the algorithm is none, meaning no signature at all, and it answers, the specified alg value is not allowed. That last one only works because the algorithm list was passed explicitly. That argument is not decoration. It is the line that refuses an unsigned token. And step 4, which we now know is a different question. Look at the order of these lines, because the order is the lesson. First, who. The dependency runs the identity check and gives you a user ID. Second, may they. Does this user hold the permission this route names? If not, 403. Third, this exact object. Does invoice 88 actually belong to this user? Because a role that says you may delete invoices does not say you may delete that one. Object-level ownership is still a separate check every single time, even with a role that allows the action in general. 2 details worth keeping. 401 means I do not know who you are. 403 means I know, and the answer is no. And the ownership check returns 404 on purpose, because telling a stranger that invoice 88 exists is already telling them something.
6 mistakes worth naming, and they all have the same shape. Somebody trusting a string too early. Putting the token in a query string where it lands in access logs, proxy logs, browser history, and the referrer header of every outbound link. Accepting algorithm none, which is what happens when you do not pass an algorithm list. Reading claims before verifying, which shows up while debugging and then quietly stays. No expiry, which turns a token into a password the user cannot change. Storing raw tokens server-side when your token table is a password table. And the last one, which is not a coding slip at all, treating authentication as authorization.
So, the whole thing as a chain of relations. Bearer is the scheme, which is how you send it. The long string is the credential, which is what you send. 2 things, 1 line. The credential is either opaque and the server looks it up, or a JWT and the server verifies a signature. OAuth 2.0 issues either one. It is not a third kind of token. OIDC extends OAuth 2.0 and adds an ID token, always a JWT, saying who the user is. And RBAC asks a different question, which your route has to ask separately every single time. If that joined a few things up, go and find the permission check in your own routes today. Hit like and subscribe so the next one finds you.